Okay, so before we get into reviewing how to write an equation from a graph or using slope-intercept form, I want to make sure you know how to calculate out the slope. So if you are given a coordinate grid where there are 2 points on that line, you can calculate the slope just by counting on the graph the rise over the run, or you can use the slope formula, which is here, and subtract the difference in the coordinates. So slope is always the change in the rise, so the vertical distance, over the change in that horizontal distance. So if you were to count on the graph the rise, so from one point to another point, starting here until you're in line with that other point, that's going to represent your rise. And whenever you count up, that's positive, so that number will be positive. And then when you count right, that number is also positive. If you ever count down, that's when you would use a negative for that number. So over here, when we count with yellow up, it's up 1, 2. So that means our top number in our slope is 2. And then when you count to the right to hit the other point, 1, 2, 3, that would represent a run of 3. So the slope for that line is 2/3. So again, rise over run. And you could also use the slope formula. So in this case, we're subtracting our y-coordinate. So if I just quickly use the slope formula for this, it doesn't matter which point you assign as first point or second point. What matters is if you start with this point, so using the y-coordinate minus this y-coordinate, when you subtract for your x-coordinates, start with that point and subtract the other one. So our change in our y-coordinates, so 8 minus 6 is going to represent our top number, and that's our change in our y-coordinates. And in our denominator, so starting with 4, 4 minus our x-coordinate of our other point, so 4 minus 1. And this would simplify 8 minus 6 is 2, 4 minus 1 is 3. And we end up with that same slope that we counted on our graph. So again, for counting up 2, to the right 3 until you hit that other point. This other example, if we only use the slope formula, you're going to subtract your y-coordinates over your x-coordinates. So if we just say that this is our second, representing our y2 and x2, so our second point, you would have 7 minus the y-coordinate of our other point, so 7 minus 2, and then negative 3 minus 1 for our denominator. 7 minus 2 is 5, so our numerator is 5. Negative 3 minus 1. Think of that as adding the opposite. So negative 3 plus a negative 4, or sorry, negative 3 plus a negative 1 is a negative 4. So this would be a slope of a negative 5/4. So it's important to remember how to calculate the slope. The other thing that we talked a lot about in other units is writing an equation in slope-intercept form. And slope-intercept form just looks like y equals mx plus b, where m, the number multiplied by x, that's always going to represent your slope. And b, that represents your y-intercept. And that means that's where it's crossing your y-axis on a coordinate grid. So this number refers to that point on that line. So our vertical axis, if this is our y-axis, this point here is on this line. So if it was a negative 3, it would be at negative 3 on that line. And then that slope is just like how we calculated it out in this slide here, 2/3. If the slope is 2/3, then this number here would be 2/3. So just remember this form, y equals mx plus b, for slope-intercept form. And in the functions unit, they would have it written as f of x equals mx plus b, because y and f of x are interchangeable. They mean the same thing. But m, so the number multiplied by x, is always going to be your slope. And this last number is always going to be where it crosses your y-axis. So just a few examples. This first one here, the slope of this line, the number multiplied by x, the slope is 3. So m for this one would be 3 over 1 if you had to graph it. The bottom number would be 1 because 3 over 1 is the same as 3. And our y-intercept, so where it's crossing our y-axis, is at a positive 4. So if you think of our y-axis, you count up to the positive 4 on our y-axis. Second one, our slope in this one is a negative 1/2. The slope is just the number, it's not including that x. So the slope for this one is a negative 1/2. Our y-intercept is a negative 6. This minus goes with that 6. So it's crossing my y-axis at a negative 6. And the last example, my slope for this one is a 7/6 and a y-intercept of a positive 2. That means it's crossing my y-axis at a positive 2. So be familiar with slope-intercept form. It's always going to look like this, where you've got a number times x and then plus or minus a number. Quickly example here, if I had y equals 5x, this is also in slope-intercept form. It's just then the y-intercept is actually at 0. So it's crossing right at that origin. You don't typically write the plus 0 in an equation, but just know if this piece was missing, then it would cross your y-axis at 0 and have a slope of 5. You may have to transform an equation to get it into slope-intercept form. That just means solve this equation for y so that your equation looks like y equals mx plus b. So we want to get y by itself, so we have to do something with this 2x term. Since it's positive, you would have to subtract 2x off of each side so that my 5y is by itself, because 2x minus 2x, they cancel each other out, and you're left with 5y equals either 15 minus 2x, or if you flip-flop the order of those, you would have a minus 2x and a positive 15. And then since we want y by itself, our last step is to divide by 5 on every term so that we have y equals a negative 2/5, so our slope is a negative 2/5 x, and then 15 divided by 5, so plus 3. So now this equation is in slope-intercept form. I can see my slope of a negative 2/5, and it's crossing my y-axis at 3. And then if you have to graph an equation in slope-intercept form, always start with your y-intercept. If I know that this represents my y-intercept, that means it's crossing this y-axis at a positive 2. This is 0 on my y-axis, so a positive 2 is here. This means that my line, this equation, is going through this point. And then since my slope is a negative 4, since we want it as rise over run, think of this as being negative 4 over 1. Since this is negative, we count down. So we would count the rises down. So 1, 2, 3, 4. And then my run was a positive 1. When it's positive, we count to the right. Here is that second point on that graph, and you can connect them with a line. So again, start with your y-intercept at a positive 2, so it's crossing my y-axis at a positive 2. Since my slope was negative 4, you want it to show rise over run, so write it as negative 4 over 1. The negative 4 is when you count down 1, 2, 3, 4 into the right one. And again, if this was function notation, your equation would look like this. F of x equals negative 4x plus 2. The only difference is instead of y, we used f of x, and you'd graph it the exact same way. Another example, y equals 3/2 x minus 5. Since my y-intercept is at minus 5, that means it's crossing my y-axis at a negative 5. So 1, 2, 3, 4, 5. Here's my y-intercept. That represents this number here at a -5. Now my slope is positive. It's 3/2, so that means I would count up 3 for the rise, because it's rise over run. And since 3 is positive, we count up 3. So 1, 2, 3, into the right 2, because my denominator was 2. So 1, 2, here's that second point on that graph. And then you can connect the two. So again, if this was function notation, you would have f of x equaling 3/2 x minus 5, but you'd graph it the same way. Lastly, if you're working backwards from the equation, you have to identify the slope and the y-intercept, because we want to write our equation with the slope and then our y-intercept, which represents this number. So right away, look at your y-axis. Here's my y-intercept right here. That's at a -3. So my y-intercept is in -3 because it's crossing my y-axis at a -3. And then to calculate your slope, you just need 2 points on that line. So you can either use the 2 points that are set up for you, or if you count on this graph, since you have to count rise over run, you're looking for where that line is crossing at exact points. So here is actually another spot where it crosses right at 2 intersecting points. So you could use these 2 points. So you could see counting up 1, so a rise of 1, and to the right 2 would be your denominator. So a positive 1/2 is going to be your slope, because we went up 1 and to the right 2 until we got to another point. You can see it again if you go up 1 to the right 2, up 1 to the right 2. So the slope is the same for this entire equation. It's a positive 1/2. So then your equation will still have the y and the x, but you can easily see your slope and your y-intercept. And in function notation, you just replace the y so that it's f of x equals 1/2 x minus 3. And then another example, if it is a horizontal line, anytime a line is horizontal or if it's vertical, whatever line it's going through, so in this case it's going through y, so my equation is going to be y equals, and it's going through 4 on my y-axis, so this equation would just be y equals 4. If you had to write it in function notation, you would have f of x equals 4. And the reason why it's just equal to 4, if you look on this line, every single y coordinate is going to be 4. This one was 4, this is the 0.04, this is the 0.54, so every y coordinate is 4, so your equation is y equals 4. If it were a vertical line, let's say it's this line here going through 8, then since it's at x, it's going through our x-axis, this equation would be x equals 8. So it's going through that, all of our x coordinates of 8.